Here we're going to look at a pretty classic Japanese geometry problem that has to do with three circles that are tangent all to the same line. So I've drawn the line down here in white. So we've got this line, then this green circle is tangent to the line. This orange or maybe peach colored circle is also tangent to the line and tangent to the green circle. And then this pink circle right here we have fit in the middle of the line, so it's tangent to the line and to each of the circles. And our goal is to determine some sort of relationship between the radii of these circles. So I've named the radius of this circle x, the radius of the green circle is y, and the radius of the pink circle is z. So put another way, we want to find the relationship between x, y, and z, like some sort of equation that they satisfy. Okay, so let's go ahead and get into it. So the first thing that I'm going to do is create a couple of important triangles in this picture with which we can apply the Pythagorean theorem. So the first triangle that I'm going to look at will be the following. So I'm going to take a triangle down here. So let's drop an altitude. So this is going to have length y. This whole thing will have length y. And then another thing that I want to do is transpose this radius of the smaller circle z over to here. So we'll have this bit right here is length z. But now that means the length of everything left over is y minus z. So I can maybe put that right here, y minus z. Maybe I'll like color this in blue so we can tell that that is length y minus z. Okay, great. And then the next thing that I'm going to do is draw a line which is parallel to our tangency line, but at a distance z. So that means it's going to go through the center of this circle and through this point right here. So I'm going to draw that line right there. Good. And then the next thing that I'm going to do is connect this radius of the circle down to this center right here, just as such. And we know that this is also a radius of the circle, so this guy has length z as well. So we can like put that together and notice that that means this length on the triangle is y plus z. So at the moment we're building a triangle with one leg length y minus z, the hypotenuse is y plus z. Then we don't quite know what this is, and so we'll just give it a name. Let's say that the distance from here to here, in other words, the distance from the points, in other words, the distance between the points which are in other words, the distance between the points that are projected down for the center of these circles, let's maybe call that A. Great. And now what we want to do is notice we can bring this A up, and that's going to be the length of this side of the triangle. Good. So now we can apply the Pythagorean theorem to this, noticing that this is most definitely a right angle. And so we'll have a squared plus y minus z squared equals y plus z quantity squared. Great. So that's like one piece of information that we have gained, which relates the length of y and the length of z with this like horizontal distance down here, a. Good. Now we're going to create a very, very similar triangle, but having to do with the pink circle and the peach colored circle. So I'll kind of do the same thing that I did before. I'll extend this radius coming out from the peach circle to the center of the pink circle. Notice that's going to be length z, which makes this whole thing length x plus z. Good. And then the next thing that I'm going to do is drop a vertical from here down to the line of tangency. So we know that this entire length will be length x because it's also a radius of the circle. Then we can bring this radius over. So like technically what we're doing here is intersecting this line with the unique line that is parallel to the white line that goes through the center of this circle. So here we've got this length right here is going to be z. Good. which makes everything left over, which I'll put in blue, x minus z. So we have x minus z for that length. Great. Now we can go ahead and complete this triangle just like we had completed the previous triangle by drawing this line parallel to our starting white line. We don't know what the length of that is, but we'll call it b, which is this horizontal distance down here. Okay, great. So now we'll apply the Pythagorean theorem to this triangle over here. So notice we've got b, x minus z, and x plus z. So we can write b squared plus x minus z squared equals x plus z squared. Okay, fantastic. Okay, so I've cleaned up my picture for our last triangle, which we will draw. So notice we drew a triangle based on the pink and the green circles, and also on the pink and the peach circles. The last one we want to look at is going to be based on the green and peach circles. And we're going to do about the same thing that we did before. So what I want to start with is taking this radius, which is perpendicular to our white line, and transposing it over here. And so that will give us a segment along this radius of the green circle, which has length x. Great. But what that leaves us with up here is a segment of length y minus x. Good. Then the next thing that I want to do is notice that if I connect this point right here and this center of the circle, I'll be completely parallel to this line, and thus I'll be perpendicular to this purple line and this yellow segment as well. Good, so let's maybe go ahead and make that connection. So here with here, great. And then finally what we can do is connect this with this right here. So in other words, the center of the green circle with the center of the peach circle. Good. And now we can start making some measurements, keeping in mind that we know that this is a right angle. So notice we already made a measurement of this height, so that's y minus x. So now this hypotenuse right here will be y plus x, because notice we are going from the center of the peach circle to the edge of the peach circle, then the edge of the green circle to the center of the green circle. So we know that this has length y plus x. And then the length down here is the same thing as the length along our white line at the bottom, so that's a plus b. So this length is a plus b. But now we can apply the Pythagorean theorem to this. So this guy squared plus this guy squared is going to be equal to that guy squared. So we'll get a plus b quantity squared plus y minus x quantity squared equals y plus x quantity squared. Great. So now the next thing that I want to do is multiply out these equations and do some sort of simplification. So notice if I multiply out the first equation, I'll get a squared plus, so next I'll have y squared minus 2yz plus z squared, and then on the other side I'll have y squared plus 2yz plus z squared. Nice. So next thing that I can do is cancel out the y squared, the z squared, and the z squared, and then move this guy over, and we're going to be left with a squared equals 4yz. Good. Now we can do something very, very similar, almost exactly the same on this second equation. It's just the variables are different. And we'll be left with b squared equals 4xz. And then we can do something exactly the same on the last equation. We're just holding this a plus b quantity squared like fixed, and we'll have a plus b quantity squared equals 4xy. Great. And then the next thing that we can do is take the square root of all parts of this. And when we take the square roots of all parts of this, we'll have a equals 2 root yz, b equals 2 root xz, and finally a plus b equals 2 root xy. But now we know that a plus b equals a plus b, but that means that 2 root xy But that means that 2 root yz plus 2 root xz equals 2 root xy. But we can just like factor the 2 and cancel all of that out. And we're going to be left with the square root of yz plus the square root of xz equals the square root of xy. But then this is not actually the standard way this solution is presented, although this does give us a relationship between x, y, and z. The standard way this relationship is presented is the equation that you get if you multiply the whole thing by 1 over x, y, z in a square root. So let's see what that gives us. So that's going to give us 1 over root x, so that's like this term right here, plus 1 over root y, so that's going to be from that term right there, equals 1 over root z. And that's like our final relationship between the 3 radii of these circles. And that's a good place to stop.